This is a SToVaDiM board. This board will help you to draw the Lewis structure of the covalent compound step by step. It is divided into 3 parts. The first part will help you on how to draw the Lewis structure of the compound that only involve the formation of single bonds. The second part will help you on how to draw the Lewis structure of the compound that involve the formation of multiple bonds. And the last part will help you on how to draw the Lewis structure of the ion. Let's go to the first part, Lewis structure of the covalent compound that involve the formation of single bonds. Acronym SToVaDiM is a combination of S stand for skeletal structure, TOVA stand for total of valence electrons, D stand for distribute the valence electrons, and M stand for multiple bonds if necessary. Let's try the first example. The compound given is CCl4. Follow the steps as given in the table. The first step is S, which is referred to skeletal structure. Draw the skeletal structure of CCl4 by placing the more electropositive atom as the central atom and the more electronegative atoms as the terminal atoms. So we have carbon as the central atom and 4 chlorine atoms as the terminal atoms. Step 2 is TOVA, which refer to total all valence electron. Calculate the total number of valence electron in CCl4. The valence electron for carbon is 4. The valence electron for chlorine is 7 times 4 equals 28. Therefore, the total number of valence electron in CCl4 is 32. And then, subtract the bonding pair electrons in order to get the remaining electrons to be distributed to the terminal atoms. Since we have 4 bonding pair, which is equal to 8 bonding pair electrons, the remaining electron is 24. Step 3 is D, which refer to distribute the valence electrons. Place the lone pair electrons based on the number of remaining electrons in TOVA to all the terminal atoms to achieve octet configurations. So, we will distribute the 24 electrons on chlorine atoms and make sure all chlorine atoms achieve octet configurations. Any remaining electrons after all terminal atoms have achieved octet, place it at the central atom. For this example, we do not have the remaining electron. Let's check the octet configuration for all terminal atoms. And yes, all chlorine atoms have achieved octet configuration. Step 4 is M, which refer to multiple bonds if necessary. If the central atom has not octet yet, move the lone pair of the terminal atom so that the lone pair is shared between the central and the terminal atom to form multiple bond. But for this example, carbon is already achieved octet configuration, so this structure does not involve the formation of multiple bond. Now, we have the correct Lewis structure of CCl4.